In this video, we're looking at direct proportion. So we're talking about situations where we have a graph, we are looking at our x variable and our y variable, and we're saying as x changes, y is going to change. And in direct proportion, as x gets bigger, right, as x increases, y is in the same thing, it's doing the same thing, it's going up as well, okay? As x increases, y increases. Now direct proportion is very different to some because it goes directly through the origin of the graph, so directly through 0, 0. It must start at 0, 0 before it continues. Now it can continue on a small gradient or it can be a very steep gradient, but it must start at that 0, 0 point. Okay, so we've got two situations here where we've got x and y variables. So really, again, these are coordinates. So this is 0, 0, this is 1, 4, remember, when we are graphing. So we can tell straight away that this one might be direct proportion, and we are trying to determine if it is. And this thing here saying 0, 0 says, yes, it went through the origin. So that's a good start. We can say, right, might be on track to figure out if this is direct proportion. What we want to do now is find the relationship between as x moves up in one amount, what is y doing? So let's actually have a look. As x goes up by 1 each time, y is going up by 4, right? So plus 4, plus 4, plus 4. So it looks like as 1 moves up by 1, y moves up by 4 each time. So it looks like it's starting to seem like as x goes up in one way, y goes up as the other. So what we want to look for is something that says y is proportional to x, right? So have a look at that symbol, is proportional to, it's like a little fish there. As x changes in one way, y is going up in another. So what we want to be able to say is y is equal to some number multiplied by the x, and that some number we are going to call k, and k is called the constant of proportionality, and that's the number that we multiply by x to get our y value, and it's the gradient of how steep it is climbing in that graph. So if we have a look here, as x goes up by 1, y is going up by 4 each time. So therefore, our constant of proportionality is 4. We can then say y is equal to 4 times x. And we can check that up here by saying, right, y value of 4 is equal to 4 times 1. That's correct. A y value of 0 is equal to 4 times 0. That's correct. A y value of 12 is equal to x times 4, which is 3 times 4, which is 12. So we're right there. Sometimes, though, the relationship isn't always between x and y. Sometimes the relationship can be between a different kind of number of x's. So here, if we had a look at this one, we'd say, right, x is going up by 1 each time, but y, let's see what y is doing. Y is changing, that's by 4, adding 4. This one's going up by, quite a bit there, 12, and this one's going up by 20. That's quite huge. So if we start to see a relationship where the x is going up in a nice uniform amount, but y isn't, we have to look at different kinds of iterations or ways of looking at x. So the first step you should do is sometimes we can't say that y is proportional to x. In this case, we can't, it isn't. But we can say y is proportional to, for example, x squared. So we can start our x squared line here and go, okay, let's see if there's a relationship between x squared and y. Let's actually do that now. So 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. Now we can see it's not going up in any kind of uniform amount either. Right, plus 3, plus 5. It's not really doing much there, but now we can look at the relationship between these kinds of things here, okay? So, even though they're going up in a very strange way, what we're trying to prove is that y is equal to our constant of proportionality multiplied by x squared. So what number are we multiplying by the x squared to get our y value? How did we get from 0 to 0? Well, we'll have to come back to that one. How did we go from 1 to 4? Well, In this case, we can add 3 or we can multiply by 4. So we'll save off on that. We've gone from 4 to 16. Well, we can add 12 or we can multiply by 4. You can start to see a pattern. How did we go from 9 to 36? Well, we can add quite a few or we can multiply by 4. So now we keep coming back to this one constant pattern. What we have here is y equals 4 times x squared value. You might go through this whole procedure and figure out, you know what, it's not, y is not in proportion to x squared, and you might have to go to an x cubed to find the pattern. But it's always about trying to say, what did we do to x to get to y, so we can find our constant of proportionality, or that number we multiplied by our variable to get our other variable.